Welcome back to my school bus conversion project. It's been a while since my last video. The plan for this video was to complete the electrical system for the bus so I could take it off grid. But things didn't go to plan, as you will see. The first step is to install struts to allow the side solar panel wings to fold out. I will let past me do the explanation on the math for that. I'm preparing to install gas struts on my side wing solar panels so that it's easier to raise and lower them. But to do that, I need to know exactly where to mount them. So this is what it looks like. This is the solar panels and this is the side of the bus here. And the gas strut is going to come out and hold it up like this. Actually, I think that this part is at the top, not at the bottom, but that doesn't matter. The point is that we need to find out how far down to mount the bottom of the gas strut here, and how far out to mount this side here. Now, when this folds down, this gets compressed. So it's going to be some final length up against the side of the bus like this. So the thing to determine is where to mount it so that it reaches its full range of travel as it moves from fully extended when the solar panels are out to fully compressed when the solar panels are down. So this is a use for some trigonometry. So what we want to find is this length here. We'll call x. We know this length is the length of the extended gas strut, and that I have the specifications for the gas strut. So the extended length is 507 millimeters. This length is going to be the compressed strut plus this length x, because as this folds down, there's going to be this same length here plus the compressed length. So the compressed length of the gas strut is 307 millimeters. So this whole length here is going to be 307 plus x. So now that we know that, how do we solve for x? Well, this is a right triangle because the solar panel wings stick out straight from the side when they're extended. So we know from the Pythagorean theorem, a squared plus b squared equals c squared. So here we have, for our a and b, we have x and 307 plus x. So, and if we multiply that out, we get, and we can simplify that and put it into the more conventional form of a quadratic equation. And now we can solve this via the quadratic formula, which, if you remember back from middle school, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here we have a is 2, b is 614, and c is negative 162,800. So we can plug that in, and that simplifies down a bit. And if we take the square root of that, we have, and we don't want the negative value because we're looking for something positive to use here. So we're left with x equals 682 over 4, or x equals 170.5. So there's our answer. We need to put the end of the gas strut here 170.5 millimeters out from the hinge. And then we can put the bottom 307 plus 170 millimeters down, which we can find just by putting the hinge up and marking where the bottom is.
The next step was to make the plunger locks, which would hold the panels in place while driving. These spring-loaded plungers are designed to be welded on. To make sure that we can do that without damaging any of the internal components, we first remove the internal parts. Well, not my best weld ever, but not too bad considering I haven't TIG welded in over a year. I also installed these maximum power point tracking charge controllers so that I can charge my batteries from the solar panels. And I bought an electric car. This is a 2017 Nissan Leaf. The idea is that I would tow it on a trailer behind the bus, and it can charge up during the day from the bus's solar panels. It would take a day or two to do so, and I can use it to go and get groceries or whatever and not need to use any gas. I also started working on some things inside of the bus. I built a folding frame for my piano keyboard, and I also got started making drawers that would slide underneath of the couch for storage. And then in the middle of the night, my battery pack had a short, and one of the batteries vented. And this kind of put everything to a stop while I tried to figure out what had happened. Okay, I have isolated the problematic battery from the rest of the pack. It appears that it has swollen up significantly, pushing the ones next to it to either side. There's no evidence that I can see of anything having fallen on it. I was hoping that maybe a mouse got in here or something and bridged the terminals, but I don't see anything in here that looks disturbed by the battery apart from the little bit of foil that was released when it ruptured. And that means that I don't know why this vented. And because I don't know why this one vented, that means that I do not trust any of the other cells that I received in the same shipment from the same manufacturer.
So I'm going to disassemble the entire battery pack, isolate the cells, and then figure out what to do. Oh, that is not sticking at all. Okay, that's the first pack out of series. Now I can separate the pairs of cells. Okay, and bank 1 is now fully separated. The reason that I'm holding the bus bars with my other hand is that the last thing that I want for them to happen is that the friction with the screw causes it to spin when it comes loose and short against another bus bar. Okay, that's bank 2 out of series. Now I just need to separate the pairs. Okay, the whole pack is electrically disconnected, and I'm going to take a break. Okay, that has freed up the front battery cells. Now I just need to take off that back bracket, and then the back ones will be free and I can finally take that cell out. Okay, and the back row of batteries are now free. I'm going to remove these 2 batteries in front of the damaged cell to give myself better access to it. There's some wrinkling on the bottom of this. Don't know how much of that is due to being on top of the fluid that leaked out of the damaged cell. It's on the bit that was closest to it. Man, that got puffy. Okay, getting out. So for now, I'm going to put these two back here for storage. I'm going to leave everything disconnected, of course, but I'm going to leave the cells here until I figure out what I'm going to do about my battery pack. It is now out, and boy, is it puffy. So you can see here at the top where the vent ruptured. I do not know what caused this, and I don't like that. I'm going to check the voltage and see whether it's still got more potential saved up.
I measured the voltage, and it's currently at 0 volts, so at least it's most likely inert. At this point, I wasn't too sure what to do, so I decided to take a bit of a break from working on the bus, and I went on some hikes. So after disassembling the rest of the battery pack, I think I discovered what caused the problem in the first place. You can see that there was definitely some arcing that occurred from the side of this battery. What I think happened is that as the temperatures rose, as a warm front came in, a lot of moist, humid air, we got condensation on the side of the battery, and because the shrink film that they're wrapped in is only really good for a few volts cell to cell, it wasn't necessarily up to the full battery voltage. So between that cell and the corner of the cell that actually failed, it shorted to the frame. So the cell didn't fail due to a manufacturing defect, but despite that, I now only have 31 cells out of a pack that had 32, and with only 31, I can't have two matching strings that are both at the right voltage. And given that it took 6 months for these batteries to be shipped to me, I don't really want to wait another 6 months to get a replacement cell. So I think I'm going to try and sell the remaining cells, and probably build a new pack, especially taking into account what I've learned about how not to design a battery box. So the new pack is definitely going to use a plastic insulating frame that contains the batteries. And I'm also going to make it so that it is easier to access the batteries in case I need to remove one. So that's it for this episode. See you next time.